Hello everyone, let me introduce myself. I'm Nafiza Zara. Today I'm going to present VibeCash, an AI-based automated expense extraction assistant. The main problem we are solving is manual expense tracking, which is tedious, slow, and full of friction. Many people often delay or even forget to record their daily expense because of the complexity of conventional forms. So, what is the role of the AI agent in VibeCash? And why did we choose an AI agent to solve this problem? Conventional apps demand very right and structured data input. However, with an AI agent powered by a large model like Gemini 3.5 Flash, the system has smart contextual reasoning capabilities. Here is the architecture we built for the VibeCash system. Through a highly dynamic Streamlit UI. Raw text from the user is sent to the Gemini AI agent, which acts as the central controller. Here's the unique part. This agent coordinates two local skills or tools. The agent calls the time server skill through the getCurrentTime function to obtain a precise ESO x601 timestamp from the host machine. Next, the agent processes the data payload and calls the CSV save skill through the save expense function to securely write the transaction data into a local expense CSV file. And finally, a structured confirmation is sent back to the UI. In this part, I asked Antigravity to analyze the project structure and explain how the data flow works from user input all the way to saving the data into a CSV file. Then Antigravity provided it analysis and automatically inserted it into a new file that it created on its own. I also tried using Agent CLI, I call it AG, by just typing it in, and it connected directly, working anti-gravitically here. And I asked whether the data flow or the analysis result were correct or if there were any mistakes. The results were displayed and explained like this, and that's the result of implementing Antigravity ID and Antigravity CLI. Now, I want to explain how the system or the AI agent was built. So here we have an Python file, which contains the code for how the program is structured. Specifically, it includes the environment and API key setup. This working environment secures our API key so the AI agent can use it safely and run smoothly. Next, we have the ADK agent runner to execute the program using the skills from the ADK agent and the runner to get the agent going. There's also main Python, which is the main program to run the result of that Python code. There's also an explanation here on how the API is secured so it doesn't get stolen or misused by unauthorized people. We also have custom agent tools. These are skills the system uses to receive user input and generate output processed directly by the AI agent with a transaction. So there are no limits. Where we try running the application, we do this by executing the program immediately runs, automatically opens in the browser, and display the main dashboard page. It also explains what the system is for, how to run it, what technologies are used, and what keys are needed. If users have their own APK, they can enter it directly there. However, since this system is already connected to my API key, it's seamlessly integrated and the status shows as configured, meaning it's connected. There are also settings here, like choosing a DOM and other necessary configurations. After that, we can jump right in and test how the system works. Here, I tried inputting a text prompt like, I just bought vanilla ice cream for $3 USD. The AI agent immediately goes to work, process it, and generates an output, which is a table with two columns, field and value. It contains several details like the item, amount, currency, timestamp, quantity, and category. All of this data goes straight into this CSV file that's already created in the system. Because it's integrated with the CSV file, the sections on the main dashboard update automatically. Things like the total accumulated transaction all change instantly according to the updated CSV file. Alright, thank you for your attention.